So, hi guys. So this is the start of us doing new instruction here during this time of us not being in school anymore. So I'm going to try to make this as simple as possible for you guys. So I'm going to number the lessons as I go through. So this is lesson number 1, and we're going to continue the skills that we were just getting ready to start before you guys ended up not being able to come back to school. So this is lesson number 1, numerical patterns. And if you remember, numerical just means number. So we're going to be talking about number patterns today. And I'm going to start off kind of simple, and we're going to work up in our complexity level until we get as high as we need to go. So before we get started on any of the math, let's talk about some new vocabulary here. Okay, so our first vocabulary word is the word sequence. And a sequence is a set of numbers arranged in a special order or pattern. And that special order could be going from lowest to highest, highest to lowest, or some type of skip pattern. So an example of that would be the sequence of 3, 6, 9, 12, 15, and 18. And this is a special pattern that follows a rule. So in this case, this rule would be adding 3 or counting by 3. So you're actually seeing the list of multiples of 3. And so when you look at a sequence, you're seeing a whole list of numbers that continues on and on forever. Our second vocabulary word is the word term. And a term is just one of the numbers that's in a pattern sequence. So when we look at the sequence 3, 6, 9, 12, 15, 18, 3 is the first term or the first number in that sequence. 6 is the second term, 9 is the third term, and so on and so forth. 12 is the fourth, 15 is the fifth, and it keeps going like that. So a term is just a number in that pattern or sequence. Okay, so let's start looking at some patterns. So we're going to start off with simple patterns. So they're simple because they're like one step. It's either adding, subtracting, or multiplying or dividing. So looking at my first pattern here, I have my first term is 3, then 5, 7, 9, and 11. So because this pattern is going from smallest to biggest, we have two options here. It could be an adding pattern or it could be a multiplication pattern. So you have to look at this and figure, is there a way to add to get from 3 to 5, 5 to 7, and so on? Or is there a way to multiply to get from 3 to 5 and 5 to 7 and so on? So when we look at this, if we would try multiplication, 3 times nothing is 5. So multiplication isn't going to work. So when we look from 3 to 5, that's an increase or a plus of 2. So we got to keep checking. So 5 to 7, ooh, that's plus 2. 7 to 9, that's plus 2. 9 to 11, that's plus 2. Which means since every one of them is increasing by 2, our rule then would be add 2 for this pattern. So if we had to continue this pattern, the next term would be 13 because 11 plus 2 is 13. And the term after that would be 15 because 13 plus 2 is 15. So we would just keep increasing by adding 2 every time. So our second simple pattern down here starts with the term of 20, and it goes 16, 12, 8, and then it could continue on and on. So when I look at this, since it's going from biggest to littlest, this has to either be a subtraction or a division. So when I look at 20, there's no way to divide and get 16. I could do 20 divided by 2, that's 10. 20 divided by 4, that's 5. 20 divided by 5 is 4. There's no way to get from 20 to 16 using division. So then therefore that cancels that out, and I know it's subtraction. So when I look at this, 20 minus what is 16? Well, 20 minus 4 is 16. So then I check and say, oh, 16 minus what is 12? Oh, 16 minus 4 is 12. And 12 minus 4 is 18. So because I have a consistent decrease of 4, my rule is subtract 4 each time. Okay, continuing on to a few more simple patterns. Looking at this next one, I'm going from 2 to 6 to 18 to 54 to 162. Oh, starting off small and getting big fairly quickly. So knowing it's either adding or multiplying. So when I look at this, I could say, oh, 2 plus 4 is 6. Is 6 plus 4 18? No, 6 plus 4 is 10. So it's not adding 4. So let's look at it again. So how else can I get from 2 to 6? Oh, I can do times 3. So let's try that, times 3. 2 times 3 is 6. 6 times 3 is 18. And then you might have to get out your calculator to check this one out. but 18 times 3 is 54, and 54 times 3 is 162. So you can get your calculator out and double check me, or you can just trust me on that, but it is true. So in this case, because it's times 3 each time, that's our rule. And then our last one here is 500. First term is 500, 100, 20, and our last term is 4. So we're going from biggest to littlest. So you're probably saying, right away, subtraction isn't going to work here. So then our choices is division. So let me think about this. 500 divided by what is 100? And 100 divided by what is 20? And 20 divided by what is 4? So when we get to 20 divided by what is 4, that's probably where it's the easiest. So it's like, oh, that's divided by 4, so 5. So let's check here. Is 100 divided by 520? Oh, yes, it is. And is 500 divided by 500? Oh, yes, it is. So 4 times 5 is 20, 20 times 5 is 100, and 100 times 5 is 500. And that's one way of checking it instead of the division is to go and do the opposite operation. So then when I look at this, it's consistently dividing by 5. So our rule is divide by 5. And look, I have that fancy division sign in here, okay, that algebra division sign. So we are dividing by 5 for that simple pattern. So it's a simple pattern because each time the same thing is happening and it's just one operation. Okay, so you should be able to follow this pattern and continue going. Like in the one up top here, I could continue going and I could do 162 times 3, and I could figure out that the next answer is 486. Okay, and I could keep doing that and going and going and going. Okay, so let's look at something that's a little bit more complex. Okay, so when I look at this pattern, my first term is 3, and then I jump to 10, and then 38, and then 150. So looking at this, I'm going from small to big, so I think it's either adding or multiplying. So if I try addition, 3 plus 7 is 10, but 10 plus 7 is not 38, and 38 plus 7 is definitely not 150. So let's look at it as multiplication. 3 times something equals 10. Nope, that's not possible. The closest I can get is 3 times 3 is 9. So there must be something different here. So this is what a complex pattern could look like. This is a complex pattern rule. So I'm actually doing 2 steps to get the next number. So what I'm going to do is take the first term, multiply it times 4, then subtract 2 to get my second term. So when I look at 3 and I multiply it times 4, I get 12. And then when I subtract 2, I get 10. And then if I do the same thing with 10, 10 times 4 is 40, minus 2 is 38. And I continue that on with my next number. Okay, so 38 times 4 is 152, and then when I subtract 2, it's 150. So this is a complex pattern because you have to do 2 steps to get from one term to the next term. Okay, so let's look at another one. So I've given you the rule for this second one. It says start at 100. The rule is divide by 2, then subtract 10. So if I start at 100, my first number is going to be 100. And then if my rule is divide by 2, then subtract 10, well, 100 divided by 2 is 50. And if I subtract 10 from 50, my next number is 40. So then I continue the rule, divide by 2. 40 divided by 2 is 20. Subtract 10, 20 minus 10 is 10. And for that one, I have to stop because if I don't stop, I'm going to end up in negatives, which is not where we're going for 5th grade. So I'm going to click here, and you're going to see that the rule that I just wrote out matches what I already had underneath the little magic box. So following that rule, it gets smaller, and then we have to stop because we don't want to go into our negative world. Okay, but these complex patterns have where you have to do 2 directions from one term to the next term. It won't happen very often for you to have a complex one, but every once in a while it will. There's one more type of complex pattern, so I'm going to talk about that next. So here's our next type of complex pattern. So let's look at this. I'm going from 2 to 4 to 7 to 11, 16, and so on the whole way down through here. So it's getting bigger, and I'm going to tell you it's addition. okay? So when I look at this and I go and I add 2 plus something equals 4. Well, 2 plus 2 equals 4. But 4 plus 2 does not equal 7. Okay, so 4 plus 3 equals 7. So it was plus 2, then it was plus 3. So then from 7 to 11, 7 plus 4 equals 11. From 11 to 16 is plus 5. From 16 to 22 is plus 6. Plus 22 to 29 is plus 7. And then plus 8 from 29 to 37. So this type of complex pattern, it's not a consistent math each time. It's a consistent pattern of each adding part getting bigger by 1. So that's what makes it a little bit more complex, is it's not the same thing each time, it's increasing by 1. So let's look at another problem like that. So down here at the bottom, I have my first term is 1, then 2, then 8, then 64, then 1024. And you're going to notice that instead of commas, I have semicolons. They're used because one of my numbers already has a comma in it. When you start having numbers with commas, you can't separate the terms with commas because it gets too confusing. So the separations become semicolons so that they don't get blurred in with the commas that are happening. So let's find out what's happening here, okay? So to get from 1 to 2, I can either add 1 or multiply times 2. I'm just going to tell you it's times 2, okay? So then to get from 2 to 8, it's times 4. To get from 8 to 64, it's times 8. And then to get from 64 to 1024, it's times 16. So let's think about this. Pause for a moment and think, what is happening with this more complex pattern? It goes times 2, times 4, times 8, times 16. Okay, so think about this. So each time the amount that I'm multiplying by is actually doubling. Okay, so when you think about 2 times 2, it's 4. When I double 4, I have 8. When I double 8, I have 16. So the next number that if you were going to continue this and do another term, it would be, what's the double of 16? 16 times 2 is 32. So we would be doing times 32. So I'm going to pull out my calculator here. 1024 times 32. Our next term, whoo, this is a big one, would be 32,768. So that's getting a lot bigger. Now you won't see these types of complex patterns very often, but they can come up. Okay, so I just wanted to show those and introduce those. We'll focus mostly on symbol patterns, but I just wanted you to have an introduction to that. Okay, so I'm going to have you guys pause and maybe pull out a piece of paper or just kind of think these through and see if you can figure out what they are. And when you're done, come back and check the answers. Okay, guys, here are the answers. So when I start at 7 and add 9, my first term is 7, add 9 is 16, then 25, 34, and 43. For the second one, start at 12 and multiply by 5. My first term is going to be 12, and when I multiply by 5, I get 60. Multiply by 5, I get 300. Times 5 is 1,500. Times 5 is 7,500. So those are my first 5 terms for that one. And then the last one, I had to start at 3, add 4, then multiply by 2. So 3 plus 4 is 7. 7 times 2 is 14. So my second term is 14. Then 14 plus 4 is 18. 18 times 2 is 36. 36 plus 4 is 40. Times 2 is 80. And then 80 plus 4 is 84. And 84 times 2 is 168. Okay, guys, so that's the end of the lesson on numerical patterns. I am also putting on some IXL links for you to go into to practice today. And tomorrow we'll be looking at pattern tables. So part 2 of patterns, numerical patterns, is happening tomorrow. And so look for that lesson tomorrow morning. Have a great day.